Good morning, ladies and gentlemen. As you have heard, using this building right behind me as an example, I'd like to show you how a GEZE smoke and heat extraction system functions. Oh, looks like a storm's coming on. That can be quite dangerous out here. It could also ruin my suit. I better go inside. Well, at least in here I can manage to stay dry. Fires can be caused by a multitude of reasons. An overloading of power sockets or accidents with defective electrical appliances, to name only a few. Smoldering fires are especially dangerous, for they can remain undetected for a long time, and the toxic smoke they can produce can have fatal results. In order to prevent that, public buildings like this office complex are bound by preventive fire protection guidelines. Preventive fire protection begins by keeping emergency exits and escape routes smoke-free. This is essential so that people can quickly escape to safety. These tasks are carried out by smoke and heat extraction systems, for short RWA. As the name already implies, smoke and heat extraction systems efficiently dissipate smoke and heat from the building. The doors and windows in the lower part of the building create the air supply vents. Windows in the upper part are the outlet vents. Natural smoke and heat extraction systems consist of extraction systems for incoming and outgoing air, an emergency current control system, alarm buttons or sensing devices, and an automatic release, for example, smoke alarm. Installing a smoke and heat extraction system is often made more difficult by having to assemble the mentioned components, which are all produced by different manufacturers. The great thing about GEZE is that, with us, all the components are available from one source. As a GEZE customer, you have a highly efficient partner and absolutely no interface problems. Let's take a closer look at the individual elements of a smoke and heat extraction system. On the door behind me, you can see the RWA K600 retractable arm drive. Doors equipped with this opening system easily create a large amount of space for the incoming air supply. On this window, you can see the spindle drive opening of the RWA 100E. Within only 60 seconds, this system opens the window to its entire opening width. Now the only thing missing is an emergency power supply unit. The emergency power supply unit, MBZ300, takes over the supply, coordination and monitoring of all connected venting system and alarm components. Smoke. I've just been talking about its dangers. Now we can take a look at how the smoke and heat extraction system actually works. It's starting to get very uncomfortable in here. I can hardly see a thing. Luckily, the smoke detector immediately sets off an alarm. But I can also activate the emergency switches, which likewise trigger an alarm. As soon as the emergency power supply unit, MBZ300, registers an alarm, the windows in the upper part of the building are automatically opened, so that the smoke and heat can escape. You can see that the upper part of the room is getting clear, but in order to get the lower part of the room smoke-free, additional air is required. The emergency power supply unit, MBZ300, now opens the doors in the lower part of the building. The thermal uplift and the additional air create a chimney effect, through which the existing smoke ascends and leaves the building almost completely through the windows. To make it clearer in our demonstration, opening the windows on the upper floor and the doors on the ground floor takes place in 2 stages. In reality, and to avoid wasting any time, the doors and windows actually open simultaneously. Now the lower part of the room is largely smoke-free, and the people still inside the building can escape to safety without any risk to their health. I think it's time for me to get going as well and leave the path free for the firefighters.